Hey, this time next week, you know what it's going to be? It's going to be March. What the? Ooh.
In 2 months.
Is this a leap year? Do you guys know? Let's see. No, this is not a leap year. So I guess before I sort of, I don't always script out thoughts, but I know, like I told you earlier, I'm a little bit leery or nervous when it comes to logs. So I wanted to be careful to say things in the right order. So the first thing I wanted to talk to you about is make sure that you're familiar with just basic exponentiation. So let's talk about just some basic um, math problems. What's 5 to the third? You want me to say it again? What's 5 to the third? It's 125. Very good. What is 8 squared? Good. What is 9 to the third? Yeah, it's a good way to do it. 9 times 9, get the first pair out of the way. We all know that's 81. And then 9 times 81, you should all be able to do in your head by just breaking 81 into 80 and 1. What's that equal? That was a really bad answer. What's 9? There you go. So 9 times 8 is 72. So that's 720. Got to put the extra zero, and then 9 times 1 is 9. So 9 to the third is 729. So eventually I'm going to give you a piece of paper. That's the one I meant to give you today that has all the powers on it, like 6 to the eighth power.
Yeah.
I didn't do that. You're having a field day on me back there, aren't you, Jess? I'll try to avoid any. Actually, I'll make one more. They come in threes. So, yeah. So anyhow, that's just basic exponentiation. The ones that I was a little bit concerned you might not be intimately familiar with are these. What is 10 if you raise it to the power of zero? It's not zero, contrary to popular belief. It is one. Anything when raised to a power of zero will become a one, and that includes negative numbers. So if I had like -9 and I raised it to the power of zero, again, I would get one. Got that? Okay. This is another one that I'm pretty sure we're going to have to spend a couple minutes on. Does anyone know? I should preface this. If you say the answer is -36, you're going to get a lunch detention. So let's just get that out of the way right now. Quite frankly, I think I should leave that as a standing rule for the next week or two while we chug through logarithms. If anyone thinks that a negative exponent makes the answer become negative, for every instance, you earn one lunch detention. In fact, on the second instance, we'll double it and make it two. So let's get that out of the way right now. The answer is not -36. You can tell that little speech was the result of decades of this. So I'm playing defense here. It is exactly that, Will. Very good. So you might go like, why does he know that? I don't actually know. He must remember something maybe from an old algebra lesson or something like that. But if you didn't piece it together, let's do a couple more with negative exponents just so you can lock in and kind of click that into place. What is 4 to the -3rd? Follow Will's example. You don't get to answer again, Will. It's 1 over 64. Good job, Nick. All right, let's go again. How about 10 to the -4th? You shouldn't need a calculator, and I'm only saying this because powers of 10 are just ones with zeros on them. So like 10 to the 1th is just a 1 with, well, 1 0. 10 squared is a 1 with 2 zeros, right? So what's 10 to the 4th? Well, it's a 1 with 4 zeros, right? Anyone, did we as a class crack the code? What's happening when we have a negative power on something? What is it really doing?
Um,
Yeah, it's inverting it, right? And if I give you something like 5 and I ask you, so let's go back to this one over here. You all know now what 9 to the third is. What would 9 to the negative third be? 1 over 9 to the third. Very good. So negative exponents do not make answers become negative. We need to get that out really, really firmly and clearly and quickly, okay? Negative exponents do not affect the sign of your answer. What they do is they affect whether it's an uppy or a downy number. All right? Got that? Any questions about that? Okay, having said that now, I'm going to start messing with you a little bit, and I'm going to put a statement up here. And I'm going to tell you that a log with a base of 5 of 125 equals 3. And this is where we dive in. We'll do a couple, and then I'll get through some vocabulary with you. I don't suppose you've ever had a reason to see a logarithm before, but let's take a look at that statement there and analyze how does that come to exist based on something we talked about a few minutes ago. Here, I'll give you another one. Just maybe having a few examples can help you um, to kind of lock in, right? So what if I said that log base 8 of 1 over 64 equals negative 2? Or what if I said to you that log base 2 of 16 equals 4? So on and so forth. That should be enough evidence on the board right now to have you be able to make a conjecture. Not knowing what a logarithm is, you could still probably sensibly reason through why I wrote that, or like what's the connection there. Anyone want to take a stab? The numbers and the problems are things that we just discussed. Maybe not those exact numbers, but first one, yes. How can you use the numbers 5, 125, and 3 to make a truthful statement? How are they related? Say again?
Fine.
Oh, so hold on. According to Parker, he says if I take 5 and I raise it to the power of 3, I get 125. That seems to be pretty solid. But any good mathematician, scientist, whatever, will tell you that if it happens once, it could just be a coincidence, right? Let's see if it happens 4 times in a row, 3 times in a row. Does 8, when raised to the power of negative 2, equal 1/64th? Sure does. Does 2, when raised to the 4th power, equal 16? It sure does, because 2 times 2 times 2 times 2 is 16, right? So let's take a look at so these are called logarithmic equations. Let's take a look at their related exponential equations. So if I were to sort of maybe justify myself for the first one, I could say what Parker said, that 5 raised to the power of 3 equals 125. Logarithmic on the left, exponential on the right. How would I rewrite the second one? 8 to the power of negative 2 equals 1/64th. And the third one? 2 to the power of 4 equals 16. You guys have all taken sort of like an earth science class, right? Do you guys study the water cycle in earth science? Do you know what that is? Have you seen those pictures with the arrows where the water goes like from the ocean and then it goes up into the sky and then it falls from the clouds back to the earth and then it cycles like a circle? Have you seen that picture before? I don't imagine there's any way that you're in 11th grade and that you haven't seen the water cycle before. I refer to this, I started doing this years ago as the water cycle, just because that's to me something that it looks like and that I think helps people, because there's going to be a lot of times coming up where I ask you, what should we do? And you'll say, like, hit it with the water cycle. And that's when we start several days from now converting logarithmic equations to exponential equations, that water cycle is what's going to be our out. It's like our ticket, it's our door, it's our escape hatch to leave logarithms and enter exponentials. So take a look at that connection. And what I'm going to do now is I'm going to ask you to evaluate a logarithm. And I'm not going to give you the number on the right. I'm just going to ask you to evaluate it. So try this for me. It's a math problem now, okay? It's not going to be an equation. I'm not going to complete the puzzle for you. What is log base 5 of 25? The correct answer is 2. Because you ask yourself, what would I have to raise 5 to as an exponent to make it equal 25? And the answer is 2. So log base 5 of 25 has a value of 2. It's no different than if I said, what's 2 plus 6? You would say 8. It's just something you evaluate. It's just a math problem. Let's go again. What is log base 10 of 1,000? By the way, I contemplated today, I'll show you right there. You can't see it, but on my note card, I scribbled out something about log base 10. I decided to save natural logs and common log lesson for either tomorrow or tomorrow. I'm thinking probably tomorrow, but it could be tomorrow. The answer is 3. And the reason is because we're seeking the power of 10 that results in 1,000. Okay, let's go again. Log base 9 of 181st. Again, the question I'm asking you is what exponent would be needed on the 9 to make him equal 1 over 81? I need a negative logarithm because I'm causing that inversion, that reciprocation, the flippy flip. How about this one? Log base 7 of 1. The fact that I'm hearing more voices now tells me that the light is either on or dimly starting to come on. But yes. Okay, so let's talk vocabulary now. I can't get through the rest of this. I can't get really through the next little bit of this if we don't talk about some vocabulary. So logarithmic equations like this consist of 3 parts, and I need you to know who they are so that we can all use words. You know, I've never given you a vocabulary test before, and I'm not going to now. But if we don't know the vocab, then we sound clumsy when we try to talk to each other about this. So first, and I'm going to see if you want to guess. I'm thinking that one of them you'll guess, the other two, one of them you might guess. Anyone want to guess what this number down here is called? Good job. Every logarithm has a base. I just said this one a minute ago, but I wouldn't expect you to have caught it, but perhaps you did. Anyone know what the 0 is called? Or, I mean, any number that's in that position. The quote unquote answer, if you will. I don't expect you to guess this one. I did say it a minute ago, but I said it in such passing that I wouldn't have thought you would, pick up on that. That number is called the logarithm. And then this one, no one in the history of 30 years of doing this has anyone ever guessed this one, but the 1. There's 0 reason why you would know this unless you had done this before. Every logarithm has one. It's called the argument. So every log consists of 3 parts. It consists of the base and the argument. And then the logarithm itself is the key to the puzzle. The logarithm is the exponent that's required to turn the base into the argument. It's a lot of words, right? So let's run through and evaluate a couple more, and then we'll talk about some rules. There are some rules with logarithms that you'll just have to accept. 2 of the 3 rules make a lot more logical sense than the third. So how about this one? Log base 4 of 4. What's the little guy down below called again? What's the big four called? The argument. Good. And what we're looking for is the logarithm. We're looking for the exponent required to turn 4 into 4. What is it? It is 1. Good. This is in math something that I say this word, and there's no way like a college professor would agree with what I'm going to say, but I just come up with words that I think help the students that I teach. I call these redundant logs. And another example of a redundant log, I could make it look as bad as I want to. I could put log base 14 of 14. What's the answer? It's 1. So it's redundant in the sense that I'm just trying to turn 14 into himself. Like there's only one way to turn a number into himself using exponents, right? Is to give him an exponent of 1. So those redundant logs, that's how that works. How about log base 5 of 625? This is where having that power sheet will help you. It is 4, and I'm not sure that you were positive about that, but you used your good, powerful brain to figure out that that's the only thing, assuming that my answers today are going to be nice answers and that I don't need some like a calculator. Or when I was a kid, we used log tables. We had tables in the backs of books. Um, Older folks would remember those sorts of things, right? Did it for trig functions and logarithms and stuff like that. So again, assuming that the things I'm going to give you are not decimal values, then that was a really good, logical, educated stab. Nice job. How about log base 4 of 1/16? Good job. One more, and then we'll talk about some rules. Log base 3 of 1 over 243. Let's run through some powers of 3. Let's start at 3 squared. We all know 3 squared is 9. So if we go to 3 to the third, we can just take his predecessor, 9, and hit him with another 3. What's 3 cubed? It's got to be 27 because it's the previous answer times 3, right? Therefore, what's 3 to the fourth? And to do 3 to the fourth, you can break it up into 3 squared times 3 squared, right? What's 3 squared? 9, right? What's 9 times 9? So 3 to the fourth has to be 81. So once I know that 3 to the fourth is 81, 3 to the fifth equals what? It's got to be 243, right? So what's the answer to log base 3 of 1 over 243? -5. We need the negative. Remember to cause the flippy flop. All right, let's talk about some tricky ones here. And believe it or not, we're almost done for the day. I didn't want to do too much today as far as the notes are concerned, like we're almost at the end, okay? But I did want to make sure we talk about the rules. There are some things that we have to abide by, and one of them exists here. Yeah, there's a reason that you're struggling with this. Think about what I'm asking you. Now that you understand logarithms way better than you did a half an hour ago, I'm asking you to take 7 and raise it to a power. I'll put a box there and have it turn into 0. How do you do that? You don't. Exactly. And sometimes in mathematics, when we understand how things work, we can almost develop our own rules. We can understand from this, if we understand what a logarithm is, that there is no way in God's green earth that I am ever going to raise 7 to any power. As you've learned today, you can raise 7 to a positive power and it'll get bigger. You can raise 7 to a negative power and it'll become a fraction, a really small fraction. But can you ever take 7 and raise it to a power and make it turn into 0? The answer is no. Therefore, we say that this expression is undefined. It does not have mathematical value. So on that note, let's do this one. You will see that sometimes I put the arguments of my logarithms in parentheses, and sometimes I don't. You'll see the same thing with textbooks, standardized tests, quizzes. I generally have a reasoning behind it, but I don't want you to think that it means that there's anything different. I just, with sometimes with fractions and negatives, I like to parenthesize my argument. Don't think that that you have to. There will come a day when we have to for other reasons, but this is not that day. So I just want you to get used to it. 5 to what power equals negative 25? It is also undefined. And hopefully, we didn't have to take that long that time to cross that bridge. Again, think about it all you want. Raise 5 to whatever power you want. I don't care. If you raise 5 to a positive power, it's going to get bigger. If you raise 5 to the power of 0, it's going to equal 1. If you raise 5 to a negative power, it's going to become a fraction. But notice, in none of those scenarios does 5 become a negative number. It is impossible to turn 5 into negative 25. Therefore, we have another undefined. Got it? Having said that, I present to you based on that. I'm going to bracket these. So if you're taking good notes, you can kind of do the same thing. These can be your examples if you want to, but the argument of a log must be, I'm going to put that in capital letters, must be positive. Okay. The argument of the log can be really small. It could be like a tiny little decimal that's positive or a fraction, but it certainly, as you've seen, cannot be 0 and it cannot be a negative for reasons that I hope you understand. Next one. This is another one that's undefined. You're on to me now. You're on to my antics. And again, I don't think at this point in the lesson that explaining why that is would be even remotely difficult for me or for you. If you understand the question behind the scenes, you understand what I'm asking you to do is impossible. I'm asking you to take the base number 1 and raise it to some power. I don't know what it is, and have it magically become 42. Is it possible? It's impossible. What's 1 no matter what power you raise it to? It's 1. How are you going to turn a 1 into a 42? You're not. And so this is another one, is rule number 2 for this one is your base cannot equal 1. And this next one, the explanation for why it is far beyond anything that I'm comfortable discussing with you guys at this point in our math careers. You're going to want to probably Google this, and then you're going to probably want to move on with your day. And this one, maybe in a couple of years, we'll be prepared to have this conversation. But I will also tell you this one. And this one, for a math guy like me, is a tougher pill to swallow. But at the end of the tunnel, there is an explanation. It's just not an explanation that we're able to have right now. But this one, I don't know what to say other than to write the rule. The base of a log, how did I want to say this? It can't be negative. And a math person would take exception to that. A truly mathematical person would say, no, I'm calling BS on this, because if you gave me like a log, if you know what you're doing, if you took a log with a base of -2 and tried to make -32, you can do that with a 5. But this expression does not have any mathematical value. The function, the logarithmic function, the domain gets gedoinkered. It becomes discontinuous. And again, that's not something I want to go into great detail with. I'm not even comfortable with it to sit here and have this conversation. And it's ill-timed at this point. Maybe like in advanced math, we can go down that road. But those are the 3 rules I need you to know. So let's go through them again real quick. Rule number 1, the argument of your log must be positive. That's a simple way of saying it can't be zero or anything below that. Rule number two, the base of your log cannot be one. I think both of those rules are the ones that we can understand. The third rule is the one that we just have to stomach, take it for now, and that is that the base of your log cannot be a negative number. Got it? I could continue to drone on. It's not going to do any of us any favors. I'm going to leave this recording alive and pause, and I'm going to hand out your next assignment. And some of you are going to plow right through it. Some of you are not. I will assume by the time I see you tomorrow that you're done with it. If that's not true, as you know, in this class where I don't collect things, that wouldn't be the end of the world. But I would assume that you're done so that tomorrow, when I start talking about harder math problems, we're not still struggling to understand the basics. Got it? Okay.